thing to work. Okay, now this is an experiment with non-resistant cells. The original cell line is called CCRF, which stands for Children's Cancer Research Foundation, Boston. CEM are the initials of the patient. This was a lymphocytic leukemia cell line that killed a little girl about 30 years ago. These are non-resistant cells in a 2 ml volume of 50-50, a mixture of phosphate-buffer-saline plus RPMI 1640 medium. There's no phenol red in this medium. The PBS, of course, holds your pH, and the RPMI gives the cell a little food that the cells need. And I thought this is a very convenient, easy way to have a medium to do an experiment. Just mix the two standard things together, and the cells are used to growing in the 1640. Of course, you don't want the phenol red in there. Okay, the measurements were done by the emission excitation ratio, and the reason for doing that, the excitation is fixed, and the reason you measure the ratio is to take out the flickering of the lamp, or if the power of the lamp changes during the day, it isn't going to make any difference. So you're continually taking a ratio. Excitation was at 494 nanometers. Emission 512 nanometers, which is for calcium. These are more or less known figures. The only thing is this machine only works on even numbers, so you can't use odd numbers. The way it's designed, you can't use any odd numbers. Okay, now this control was treated with 120 nanomolar calcium AM, and this is a non-resistant cell, and as you can see, the cells are getting fluorescent, and you're getting a nice straight line. Now this is a very early experiment. This is close to when I started, and just about the same time that they started to threaten to take my life away. It was just about then, February '97. So, and I wanted, because there was a lot of work that went in to get to this stage, so I wanted to try and get some data before they demolished the lab. Okay, now if you add 2.6 micromolar of cyclosporin A, you see that the rate goes up. So apparently, even though this is a non-resistant cell, it does have some pumping capacity. It may not be the MDR pump, we don't know what pump it is, but apparently there is some pumping mechanism that can be blocked by cyclosporin. Cyclosporin, as you know, is the drug that's used to knock out the immune system for transplant patients, and it also is a potent inhibitor of the MDR pump. Okay, this is another experiment with non-resistant cells. Now we've cut down the substrate concentration, and this is about as low as we can go with this particular instrument. And again, we're measuring emission over excitation as a function of time in seconds, and these little blips, each one represents 2-second time intervals. 10 seconds. The instrument takes 2 seconds. Each of these dots are 2 seconds. You can hardly see them on this scale. Now, with a non-resistant cell, we're getting fluorescence in the cell. And then when we add PSC, which is an inhibitor, that increases the fluorescence. So there is something in the pump that, even though this is a non-resistant cell, and of course here's the temperature and here's the date. We're moving along in time here. There is something that's blocked. Okay, what I'm going to show you now I think is very important. You will see curves like this in a book that was written by Irwin Webb in 1964, and of course he was studying enzymes entirely. And if you look at this